We've set up some security around how our users can log in. Now let's work with our firewalls. So I'm logged into the server. I'm logged in as user admin, as I can no longer log in as user root. And what I want to do is take a look at the firewall rules that are currently on this server. So we're going to use IP tables, which is pretty much the de facto firewall installed on most Linux servers. And we want to list out with a capital L all the current rules. And I'm also going to add a -v flag here so we get a little verbosity. We get a little more information. Alright, so there are no current rules in this firewall, but there are 3 chains. So we have 3 chains here. They are the input, forward, and output chains. These are the main default ones that come with IP tables. So the input is what to do with external traffic coming into the server. Output is just the opposite, what to do with traffic originating in the server, leaving the server through the network. And the forward chain is what to do with traffic going between networks within the server. In all 3 of these chains, the default policy is to accept traffic. So basically, this server has no firewall rules. It's not blocking any traffic of any kind because the default policy is to accept. You can actually make the default policy deny, where it will drop the traffic and essentially shut your server off completely from the outside world. Now, before I get into building firewall rules, I want to talk about persisting firewall rules. So any rules we make are going to be saved in memory on the server, which means when we restart the server, those rules get wiped out. So we need a way to save those. So we have some tools already. Those are IP tables save and IP tables restore. So IP tables save will simply output some text, a text representation of the current rule set within the IP tables firewall. So we see we have the input, forward, and output chain, the commit command here. There's no rules there. What we can do with IP tables save is output it to a file, let's say rules.v4, v4 standing for IPv4, our usual IP addresses. And then if we wanted to restore from those rules, we could do IP tables restore, and we'll pipe in the same file. That can be used on system startup to restore our current rule set. So we can make like a contest that works on server boot or some kind of mechanism that restores the IPv4 rules on system startup. Or on Ubuntu and a Debian servers, we can do apt-get install the IP tables persistent package. I want to save the current rule set, which is fine, and also the current IPv6 rule set. I won't go over IPv6 in these videos, but IPv6 also can be used with IP tables and also can be saved separately. All right, so I'm going to do sudo service IP tables persistent status. And it actually doesn't have a status command, but we can see start, restart, reload, force reload, save, and flush. So what I want to do here is I'll just copy and paste this so it's a little easier. I want to do the save command, and that is saving the rules to etc IP tables. So anytime we make changes to our IP tables firewall rules, we can run sudo service IP tables save. That will save them out, and when the system reboots, it will reload those rules back in. Great. Now let's get into the meat and potatoes of this. So I want to do IP tables -L-v once again, list out our current rules. This is going to be used as a web server, so what I want to do is allow in basically 3 things. SSH traffic, so I can log in, port 80 traffic, so I can make web requests to it over port 80, and port 443 SSL traffic, so we can make requests to the server over the web using SSL on the standard port 443. So let's go over some basic things we need to start doing that. We're going to add some extra rules on top of what I just said as well. First rule I'm going to do is this. Now this is adding a new rule to the input chain. So we're going to use the IP tables command. We're going to use A for add or append. We're going to tell it what chain to add it to. So we're going to make rules on the input chain because we want to control external traffic coming into the server. Then we're going to define the interface. Now the interface is the network interface. So if I run the command ifconfig, I'll get a list of all the networks, of all the interfaces on this server. We have the interface eth0, which is our public IP address, the interface eth1, which is the internal private IP address that we can use to communicate with other servers in this DigitalOcean data center. And then we have the loopback interface, which is just the localhost network. So in here, I'm going to append to the input chain. I'm defining the loopback interface. I'm saying jump, that's what J is, to the accept target. Now, what is the accept target? Well, we have separate targets we can send data to. accept, reject, deny, and other ones that you can custom make if you want. But basically what we're saying here is to accept, allow in traffic that is from the localhost network to anywhere from anywhere. And this is only on the loopback interface. So essentially what we're saying is, hey, that localhost loopback network, we know that's only getting used within the server for inter-server communication, so allow anything that hits the input chain from the loopback interface. So we can do things like take our PHP application and let it talk to MySQL over the localhost network, for example. Now the next rule is this. This is once again appending to the input chain. We're going to use M, a module. The module is called contract, connection tracking. We're going to get the state, and we're going to apply this to things with a state related and established, and we're going to accept it. Now I'll set that rule, but what I'm going to show you here is what this related and established means. So we're going to do netstat-a to list all the things about the network on the server. Now if we go to the top here, we can see that some stuff has state. So I'm logged in over SSH to this local network. This is actually the public IP address of the server. The foreign address, this is the IP address of my Macintosh connecting to it via my Time Warner cable network connection. And SSH is listening on IPv6 as well. So these are listening, this is established. So note that I am saying anything that this is able to track with a state related or established, accept it. So essentially what I'm saying here is accept my current established SSH connection. So if I just start blocking things like SSH in IP tables, I could cut off my current SSH connection to the server and I'll never be able to connect again. So what I am doing here is saying allow any related or established connections currently existing to remain existing. And that's good because I don't want to cut myself off accidentally by rejecting SSH traffic and cutting myself out of the server, so I will not be able to log in again. All right, so those are kind of the boilerplate ones. We are expecting loopback localhost network traffic. We are saying keep the related and established network traffic so I don't cut myself off by accident. Now we can get to the usual stuff that we really want. We're going to append or add to the input chain over the protocol TCP, not UDP. We're specifying TCP in this case. Destination port, that's what D port means, that's port 22, which means, you might recognize this, this is allowing in SSH traffic. So we're going to use the jump, I'm going to jump to the accept target. So now, in addition to the localhost network, in addition to currently established connections, I'm allowing any SSH traffic over port 22 on the TCP protocol. And you can see that this is allowing TCP, the destination port, SSH. SSH is just shorthand for port 22. I think we can cat etsy services and see that defined. Now let's grep for 22, and we'll see 22 is defined as SSH, both TCP and UDP in fact, but I'm just allowing TCP. But any port that we use in IP tables that happens to be in here is going to be named this stuff. So we'll see later if we even grep for 80. Port 80 traffic is going to be called HTTP, but it's really just referring to port 80. Now we can go ahead and repeat this command, but adjust it to allow port 80 traffic. So now I want to allow in traffic over TCP once again, which is what HTTP works on top of. Destination port 80, and we'll do 443 for SSL traffic. Great, so loopback, established connections, SSH traffic, HTTP traffic, HTTPS traffic, all over TCP. Now we said before that the default policy is to accept traffic, so we're not actually rejecting anything yet. If the traffic goes through all these rules and doesn't match any of these things, it's not SSH or HTTP or HTTPS or related or on the localhost network, it's actually still going to accept that traffic because the default policy is accept. So we're going to stop that. We're going to add a last rule here to the input chain and jump it to drop. Now I can do drop or deny. The difference is deny will send back a response saying, hey, that traffic was denied. Drop will silently drop it. So the connection that gets dropped actually probably will time out because it just does not receive a response at all. Whether you want to use drop or deny is totally up to you. It depends on if you want it to be kind of a mysterious why did this drop, or if you want a connection to know, hey, this definitely got denied. All right, so this is the way IP tables rules works. It will go through and start from the top and go through each rule until it has no more rules to go through. So the first rule that matches the traffic is the one that will be applied. So traffic goes in. Is it a loopback interface? No. Is it established already? No. Is it SSH? No. Is it HTTP? Well, let's say it is. It sees it, it's accepted, and that's it. If it makes it all the way down and doesn't match any rule, it finally gets to drop, which drops any traffic that's not met. Conversely, if we set the default policy to drop, then we wouldn't need this last line, and we could say just accept this stuff, and if it doesn't match any of that, then drop it. That's a little bit more of a shorthand, so you can do either way you want. Now, deleting commands is pretty simple too, so we can do sudo iptables-d to delete instead of add. Once again, to the input chain, and here things get a little interesting. I could say position 3, which is 1, 2, 3. This takes off SSH traffic. I'll just do 4. I don't want to do that by accident. Actually, let's do 5. So 1, 2, 3, 4, 5. That's the 5th rule in a row. Delete that. And we can see that HTTPS traffic is now gone. Now to get that back, we can just rerun our sudo iptables rules. Now if we do -a to the input chain, we're going to append to add to that rule list. That was on TCP with a destination port of 443. I'll just finish writing that out, except now if we just append this, that rule will get added to the end of the line here, but the drop rule is there before it, meaning any traffic is going to reach this and get dropped. No traffic will ever reach this rule. So we don't want to just append in that case. So we'll do sudo iptables-d, that's the 6th position, input chain, 6th position. All right, so what we need to do is insert it instead of append it. So sudo iptables, we're going to do capital I to insert to the input chain. We're going to go back to the 1, 2, 3, 4. We're going to say put that in the 5th position. That'll be right after HTTP in this case. Protocol was TCP. The D port, destination port, was 443. We're going to jump that to the accept target. All right, great. So that's back where it belongs in the 5th position. So the last few notes I'm going to put here, you can actually delete not just by position, but by the rule. So in this case, I want to delete the input chain where it's TCP, where it's port 22, and where it's accept. So I could define that specific rule instead of just saying position 3 or wherever port 22 was. Similarly, I could run sudo iptables-S, which has a list of all the rules currently set for all the chains here. So we can see for all the input chains, we have these set of rules, and these commands we could actually reuse to copy and paste. So if I want to delete the port 80 rule to allow web traffic, I do sudo iptables-d, and I'll ignore the -a here for append. I'll just do input, blah, 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 copy and paste this, and we can delete input TCP module TCP port 80 jaccept, and that will delete that port 80 rule. You can see it adds the extra module flag for TCP. You can skip that if you want, but it's just there in that case. That's a very handy way to also get the commands that were used to create rules where you may not understood all the flags that were used to create them. And that's it. These are basically all the rules that I use on any server. I usually just guard the input chain. I make sure that the local host network can communicate. I make sure to set any established connections so that they can stay established as I adjust these rules. And then I allow an SSH traffic, HTTP traffic, HTTPS traffic, and drop anything else. Now, if we had something like another server where we had to connect to over MySQL, you can do all sorts of stuff. So I could say input protocol TCP, and I could say 3306 for the destination port if I wanted to accept external connections to a MySQL server on this server, so we could stop firewall rules from blocking that. And basically you can do that for any service such as Redis or MySQL or Postgre or whatever might be listening on a network that you might need to connect to remotely.